All right, so today we're going to take a look at section 2.1. Um, 2.1 is about numeration systems, and some of this is going to overlap a little bit for those of you taking contemporary math. You're going to see some similar things. You'll see a lot of different things too, but there are some similarities between this and some of the things in the contemporary math book that we use. So to start with, we're going to talk about our numeration system. The Hindu-Arabic numeration system is the one that we use. Okay? So in our numeration system, it was developed by the Hindus and transported to Europe by the Arabs. And there's several properties. We're going to talk about a couple of them. One of the properties is that all of our numerals are constructed from 10 digits. What are the 10 digits in our numeration system? 0 through 9, right. So a digit is a single symbol. So we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Another property of our system is that it's a positional system. It has place value, and the place value is on the base 10 system. So in our system, when we look at our places, for instance, we have, I'll put 5 of them in here. We have the ones place, right? What's the next place over called? It's the tens place. And then the hundreds place. And then thousandths. And then the last one I've got up here now anyway is 10,000ths. And all of these are actually powers of 10. All right, so this is actually 10 to the 0. Anything to the 0 power is 1. So this is a 10 to the 0. 10 is obviously just itself, so it's 10 to the 1. And then another way to express the number 100 would be what? 10 squared. And then 1,000 is 10 cubed, and 10,000, 10 to the 4th. One way to remember the power is that the power actually matches the number of zeros. Pretty cool, right? The number of zeros matches the power. And what you see is you see powers of 10. And that's because we have a base 10 system. Any idea why? Let's do this in contemporary math. What do? We have 10 fingers, right? We have 10 fingers. That's why we have a positional system that's base 10. If we did not have thumbs, we would probably be working in base 8. Okay? Now there's some other systems that use different base systems with good reason, and we'll encounter those along the way. The first one we're going to talk about is our friends the Egyptians. Better? Yeah. Okay. Okay, sorry. Straighter. Okay. Yeah, that's good. All right, the Egyptians have a system that has not got positional bases at all. It doesn't have any bases in it. But it uses repetition of symbols, okay? So the first thing I want you to talk about is what those symbols are that they use. Now, this is an overhang from contemporary math. So if you went through contemporary math, you've probably seen these before, okay? So the first one is a vertical staff. This is the Egyptian numeral, and it just looks like our number 1, or like a L, lowercase l. And it has the value of 1. The next one they have is the heel bone. The heel bone looks like that upside down U, or the intersection symbol we encounter in different parts of mathematics. So those of you who've had this before, do you remember how much the heel bone's worth, what its value is? It's 10. The scroll, it looks like this. And the scroll has a value of 100. The next one's my favorite, the lotus flower. Looks something like that. I'm not an artist. And in keeping with the pattern, it has value 1,000. The pointing finger, which, I don't know, mine doesn't look very good, but it looks something like this when you draw it. Imagine it's sort of not really pointing, it's sort of bent. It's a bent finger. The pointing finger is worth 10,000. The next one is sometimes called a fish or a whale. Your book, this one calls it a pollywog or a burbo. Okay? So it looks like this, and this is probably the one that I draw least consistently. Sometimes it's called tadpole too. Sometimes you'll see it called that in textbooks. This one's worth 100,000. And then the last one is the astonished man. And the astonished man looks something like this. This is how this book draws it anyway. It looks like a woman, but let's pretend it's a man. Remember, this is Egypt. They wore skirts. Okay, he's worth $1 million. I think that's why he's astonished. He's excited. I mean, if you were worth $1 million, would you not be excited? Just saying, right? Okay. So the cool thing about their system is it's really easy to write stuff and to read stuff in their system, right? I mean, it's really easy to interpret what their number is versus our number, okay? So what's not so helpful is that it can sometimes result in bunches of symbols. So let's take a look at a few things. We're going to consider the value, and the value we're going to look at is this one. There's two things you can do. If you want, you can turn that into our number system. Your book is not assuming you're going to do that, though. Our book is going to assume that what we're going to do is we're going to put on our little hats and we're going to walk like an Egyptian for the next problem. Okay? So we're going to pretend like we're an Egyptian and we're going to do the problem in Egyptian. So the first question is, it wants to know what numeral comes before this value. Okay? So you know in this system that this last heel bone is worth how much? This is worth 10. So if I just look at that last heel bone and I want the number before it, the number before 10 is 9. So I can keep the 3 scrolls the same. And then the heel bone, one less than that, turns into what? 9 strokes, or 9 vertical staffs. Okay. Sometimes in books you'll see them stacked up on top of each other when you have more than a few. So you might actually see this written like this. I don't remember if your book does it or not, but if you did, it would be okay. Okay. Usually if it's more than 3, it's only the time you'll see something stacked. Do you have a question, Hannah? Yep, you're okay? All right. The next question asks what numeral comes after this value. And again, it's the 10 at the end that's causing the concern, or it causes the answer to be answered. The first 3 parts stay the same. So I still have my 3 strokes. I'm sorry, my 3 scrolls. But what comes after 10? 11, and how would you do 11 in their system? You just keep that heel bone, and you'd add that vertical staff. Any questions on that? Okay, so you're going to do a lot of things where you're looking at numbers before and after within the same base system, or the same numeration system. All right, so the value in part A does not seem to be especially efficient. Would you agree? And it's even worse if you had a lot of 9s involved, right? If you had 9,999, you'd write out 36 symbols in order to write that value in Egyptian. It's not especially efficient, but it's pretty straightforward. Agreed? Okay, so there's a good, there's a bad, but you have to recognize that as you're working on the particular systems. All right, let's do another one. Babylonian. Babylonian, if you didn't like the number of symbols in the first system, you'll like Babylonian because they only have 2 symbols. That's good news. All right, so one symbol looks like a triangle upside down, or pointing down, if you will. That triangle, and it's filled in, has a value of 1. And the other one sort of looks like a bolded less than sign. Okay? And that has a value of 10. Now, you might be looking at that and think, okay, and if I have a really big number, that sounds like it's not a good plan, right? I mean, like the Egyptians had a number that was representing 100,000. What am I going to do here? Well, what we're going to do here is we're going to involve positional base system, okay? So this has a place value system. So a place value system meaning that they have places like we do where we have the ones place, the tens place, and so forth. But they don't have a base 10 system, they have a base 60 system. Alright? So let's take a look at what they're going to do with their base 60 system. In our system, we had the ones place and the tens place, and then we had the 10 squared and the 10 cubed, right? Okay, so we're going to do the same kind of thing here. We're going to have the ones place, but because they're base 60 instead of base 10, they're going to have the 60th place. And then the next place over is the 60 squareds place, which would be 3600, just in case you're keeping track. The next place would actually be 60 cubed. I don't have that one written down. What's 60 cubed?
Wasn't it like 72,000?
Maybe. Or maybe 216? Is it 216? I think we're going to encounter the 72,000 with the minus. Yeah.
Oh, yeah.
216,000, is that one? Is that what it is for some? Okay, good. All right, so we've got this system where each of the place values are much larger than ours, right? But we only have two symbols that we have to sort of remember or know in order to work in their system. So let's take a look at what that ends up looking like by taking a value in their system. So we're going to take this value, and it's going to take you a little bit to write it out. So copy carefully to make sure you don't miss a one. So there's a triangle, and then there's 4 of what sort of look like those less than signs. And then, oh, sorry, thank you. And then you need 9 triangles at the end. Okay, so I'm going to show you if we can make it work. A cool feature. Oops. Oh, that's not what I wanted. All right, we'll do it here. Okay, so one of the neat things that the smartboard will do for me that my iPad won't is it has something called cloning. Cloning is a copying activity. So I'm going to take this, I'm going to click next to it, and I'm going to call this an infinite cloner. Okay? And it lets me do this. Fancy, right? So I don't have to write all these guys out, or at least I don't. You do, because you don't have infinite cloner on your piece of paper. But I'm going to have a whole bunch of them here at the end. That wasn't supposed to happen. Let's try that again. All right. Pretend that those are just on the end. I'm running out of space. Do I have 9? All right. Excellent. You can actually turn this infinite cloner off if you wanted to. And in fact, what I want to do is I want to erase it because I don't need it down there. Okay? All right, so this is my number to start with. You could turn it back into one of our numbers, okay? That would be a possibility, but that's not what your problem's asking you to do. Okay? The problem asks you to find the number that comes before, the number that comes afterwards. Everybody with me? Okay, so when we're looking at finding the number that comes before and the number that comes after, it's based on whatever the last value is. Just like on that last problem, it was a heel bone. There's 10 of these guys, but how much are those individual triangles worth? 1. So I have 9 of them, so if I want to know the number that comes before this value, what would I have? I just have 8 of them, right? So I'm going to have everything written out the exact same way except one fewer triangle. That's easy enough, just take one off. But what are we going to do if we want to add one on? Because that's what will come after. Yes, yeah.
You don't do any of the triangles at the end, just do another one of the greater than signs.
Right, because if I were to add an additional triangle, I'd have 10 triangles, right? But I don't express the number 10 with triangle. I express the number 10 with one of those symbols that sort of looks like a less hand sign. So I will have the same starting spot where I have the triangle here and the 4 of the less than, but I'll just have an additional less than.
So what number does that actually equal? Like what is that?
If you wanted to find that out, there's a couple of things you could do, and here's part of the problem. This is in red below. But let me show you how we would think about it. This would be our ones place because it's on the far right. At least we assume if there are any ones place, that's where they would be. And this would actually be the 10 or the 60s place, because in their system, notice a larger value 10 will come before a smaller value within their place value system. So all of this in red, and highlighted in red originally, would be the ones place. And this would be the 10s or the 60s place. I want to call it 10s place, it's the 60s place. Okay? So if you wanted to figure out what this actually is in their system, much like what we would do in ours, is you could actually take the number in that place value times the value of that place. Let me show you what I mean. So if we had 435 in our system, what we mean by that is 4 hundreds, 3 tens, and 5 ones. And we can think about it a lot like we count money, right? You can do the same thing with their system, except that you don't end up multiplying by 110 and 1. You multiply by the powers of 60. So here, this value is the value of 1. This is 10, 20, 30, 40, 50 of them, right? Okay. So you'd have 160, and you'd have 50 ones. So this would actually be the value 110, or at least it could be.
Does it matter if there were 8 since they don't have an 8? Does that matter? You know what I mean? Like they only go up to 6, so
What do you mean they only go to 6?
right?
No, they can have an 8. They would just write it with 8 of the individual triangles. So they just repeat a symbol, just like the Egyptians did. They repeated a symbol to represent more than one value of it. Yeah. Now here's something that's interesting. This numeral in part B could be interpreted as, oh, that's because I changed my problem. I wrote it down differently. So this is not going to match now. So just a second, I'll fix this. Could be interpreted as what we just did, which is 1 times 60 plus 50 times 1. Okay, sorry, I left a symbol out, and so now things don't look right. But the problem is, with their system, there's no way to tell that for sure that represents the 60th place and the ones place. What if this is the 60th place and this is the 60 squareds place, and there simply aren't any ones? What do we do when we don't have any ones in a number? We put a 0 there. They don't have a 0. So they have no way to hold that place value. Or worse yet, so none of these numbers match, just ignore this. Or worse yet, what if this is the ones place, and that's the 60 squareds place, and they just don't have any 60s? Again, if we don't have any 10s, we would put the 0 there. Well, they don't have anything to hold that place and to indicate that there's something missing, that there's a gap. Do you guys follow with me? And it gets even more hairy than that. What if this is the ones place, and this is the 60s place, and this is the 60 squareds? Like, that could really happen. They could have 2 in the ones place, and they could have, 20 in the ones place, and they could have 30 in the 60s place, and they could have the 1 in the 60 squareds place. Because they have no way that they're breaking this apart to show you that there's a natural spot. This is not good, right? Like, if you were doing some kind of bookkeeping, this would be really problematic. So, when we interpret their numbers, what we do is the way that I had it done originally. We interpret the natural breaks. Which is meaning that we interpret this is the ones place. It naturally breaks right here because we have a smaller value in front of a larger one. Because this is worth 1 and this is worth 10. Okay? And we assume one place up that this is the 60s place. That's the natural breaks that we assume. Recognizing that there's other possibilities out there for when we do this. Okay? Alright.
Is that other system
Well, yes and no. So let me give you an example from a different culture to answer your question. I had a student once in my class who knew the Chinese numeration system, that is, he grew up in China. And in mathematics, like in this math class that you're taking or whatever, they would use Hindu-Arabic numerals. It's a universal numeration system. So my daughter, who's in Ethiopia, she uses the number 3, and it looks like a numeral 3 when she does math. Okay? Universal. So math is the universal language. You all just thought it was silly. It's not. It's important. Okay? But in literature, when the Chinese use their numerals, they would actually use Chinese numerals in their literature to write out that numeral. Kind of like you will still see the numerals for Roman numerals used on public buildings and things like that. They're used, but we don't do math with them. Does that make sense? Okay. All right, Mayans are next. The Mayans at least solved one problem. They have 3 symbols. One's a dot, and it's worth 1. The second one is a horizontal line, and it's worth 5. And the third symbol looks like, I'll draw it the way this book does it. Something like that. It's supposed to be a shell, like a clam shell. I didn't say I was an artist, right? I told you that just a minute ago. It's worth 0, so at the very least, they're one step ahead of those Babylonians because they've got a 0 to represent holding a place value, and that's really a big step because that's going to end some of the issues. They've still got other issues. We'll see, but at least fixes some of the issues. Okay? Few things. They have a place value system. Their place value system, though, is not the tens like ours, and it's not 60 like the Babylonians. They have a 20 base system. Why? 10 fingers and 10 toes. And why in the world would they count on their toes, do you suppose? They didn't wear shoes. Or if they did, they were sandals. You could still see their toes, right? So this makes sense to use 20. Okay? But it doesn't just say it's a base 20 system. It has this funny word in here that says what? Modified. So what in the world do they mean by modified? Well, let me show you. They mean that they have the ones place. Well, you know what? Let me write it sort of in our notation. This is not their notation. We have the ones place. And then we would have the 20s place, like our 10s place. The next place, however, is not 20 squared. 20 times 18. Do you know what 20 times 18 is? 360. Any idea why they would really want that to be 360 instead of 400? Because that's what 20 squared would be. What's important about 360? Circles have 360 degrees. There's something else that they use to with another reason for it too. It's a calendar. You know those Mayans? World's not over. We're still here. Okay. They used or rounded the number of days in the year to 360. So 360 was a really important number. So within mathematics, they used it as one of their place value systems. Places in their place value systems.
So they knew a circle had 360 degrees, but they didn't see how that
Well, you haven't seen. Well, you've seen it for math. But yeah, there's problems in their numeration system, right? Okay, so let's get to the problems in a second. But do you remember what happens next after the 20 times 18? After that, they are going to start to do powers on their 20, okay? So they're going to have 20 squared times 18 next, and then 20 cubed times 18. Okay, so they're going to do the powers on the 20 just like they would have do powers on our 10. It's just the first time where it would have been a power, it's 20 times 18, okay? This is written vertically, however. So all of this that I wrote down here isn't really how it works. It really works like this. Here's the ones place, it's at the bottom. And I don't mean that bar to mean one of their bars, okay? I'm just sort of indicating it's a placeholder. The next value, the 20s place, is written as a value on top of the ones place. On top of the 20s place is that 20 times 18 place. And then above that, it's 20 squared times 18, and so forth. So it's written vertically, smallest on the bottom, largest values are on the top. Okay. So for instance, like if we had our number and we wrote it vertically and we had 434, well, let me use a different number. We're in 35, just so I don't repeat digits. We would write 435. Okay, smallest value, one's place on bottom, biggest value, hundred's place on top. Okay, everybody with me? Okay, so let's see what happens. Oh, here's one other thing too. They put bars underneath the dots. So if they had the number 6, it would be dot on top of a bar. Okay, so that's the order of how they do things. So if they're using a numeral, they're always going to put the dot value above the bar value, if there are dots and bars both involved. Okay, so let me do one with you. Consider the value. 2 dots, 1 line, 4 dots, 1 line. So the questions are just like the questions were before, right? Comes before, what comes after. So let's actually look at where our place value break is. So based on the last slide, I told you the dots go on top of the bars. So we would conclude that naturally, the natural inclination to include was that these 2 dots on top and this bar right here sort of go together. Okay? So these 2 pieces combined, what would they be worth? 7. And the bottom 2 pieces combined, and they would be worth 9. This is not the number 79, however. Students tell me that a lot. It's not 79. Because remember, their place values are worth modified powers of 20. So this is like having 7 $20 bills and 9 $1 bills. That's the equivalent of what we're looking at here. If somebody gave you 7 10s instead of 7 20s, you'd say, excuse me? Okay, and that's what you do when you tell me that this is worth 79. It's not worth 79, right? It's worth 149. So we're looking at this actual value. Okay, now let's take a step back and let's do what the question actually asked us to do. What numeral comes before this? So if I had 7 20s and 9 1s, what would I need for it to be the numeral before this? How many 20s would I have? Still 7, right? That doesn't change. So let's start with that. I'm going to do my 2 dots and a bar. There's still 7. Okay, then what? I need to take away a dot. Right? The number that's before is just remove a dot. So I will have how many dots? 3 dots and a line. So I have 7 20s and I have 8 1s. All right. What numeral comes after this? Well, I still have 7 20s. Okay. But what happens to that 9 on bottom? Yeah, that 9 turns into a 10, right? And how do I write a 10 in your system? Do 2 lines, 2 bars. And can you see a problem with that? Say again? Yes. Well, no, we don't have to put in a 0, but we sure would like to, wouldn't we? You would have put in a 0. Why, Kenzie? Yeah, I mean, like, we want sort of like some space in there or something, right? The reason a 0 doesn't work is because a 0 actually takes up an entire space. So if I put in a 0, it means I have 0 20s. But our minds sort of are thinking, but I want there to be some sort of a break here, right? That's sort of what we want. But they don't have that. So the 0 solved some problems. It solved the problems of what happens when there's nothing in a place value. But it doesn't solve the problem of what if we have bars, that is multiples of 5 in these place values. So this number in value in part B could be 7 20s and 10 1s, which is 150. Or it could be 17 1s, right? Or it could even be 13 20s and 5 1s. That is, we could put this dotted line break down 1. Because we just made that up. That was not their system, right? Not a good idea. This is terrible, isn't it? Because if you owe somebody $150 and somehow they tell you later you owe $265, not good. So this is one of the problems with the Mayan system. All right, the next one is the Romans. So where have you seen Roman numerals used? They're still useful. And what? Clocks? Where else?
They're using movie credits.
Say again?
They're using movie credits.
And the movie credits. Okay. I've heard that one. Very good. In history, it's actually, you know where you'll see it too? If you go to the Washington, D.C. area, you'll see it on buildings. Established dates of buildings will often be written with Roman numerals. There's another one. King's names, so like numerals behind people's names when they're, you know, like King George the First, the Second, the Third. I think you'll see there sometimes. What did you say? Chapters in books. There's one you guys have missed. At least once. Clocks. The largest set clocks. We got that one. It's okay. Huh?
Note taking.
Note taking. Do you have one in mind?
I said the Super Bowl.
The Super Bowl. That's the one I'm waiting for. Super Bowls, Olympics. You'll see them use Roman numerals when they talk about what year it is for that to happen. Yeah. Okay. Or what? Not what year, but what number of that event it is that has happened. All right. So Roman numerals. Some of them you know. That is because they're used so frequently. Still, you just know them. Okay. So what's the first one? It's an I. And your book, I can't remember if it puts the lines on top or not. Sometimes they'll just write it as a one, depending on the textbook you're looking at, or even basically the font that you're working with. And this has a value of 1. You know, at least most of us use the numeral that looks like 1. I mean, this is the third system. Our system and the Egyptian system, and now this system all use the same sort of looking numeral for the numeral 1. What's the next one? B. Again, it may have a little hat on it or it might not. And how much is this one worth? 5. What's the next one?
X.
X. And I'm going to stop writing in both forms. You guys know that you can put the little bars on top. What's an X worth?
10.
10. And as far as outlines and books go, that's about enough. We don't really need more, right? I mean, yeah, those are the ones you see used the most. And certainly the clock doesn't need any more than that. Do you remember what does come next? It's an L for 50. There's a C for 100. Before the M, there's a D. There's a D for 500, and then there's an M for 1,000. I feel like I'm on a game show. I'd like N for 1,000, please. Okay, so these are our symbols, and there is a way, and we'll do it in a second here, to get numbers bigger than 1,000 as well. Okay? So let's take a look at what to do with their system. That is some of the properties they have in their system. And I'm going to talk a little bit more in depth about this one because you do see these used a lot. And so you should be able to look at a building and be able to figure out what year that building was built in. Okay? That's something you should be able to do. All right, so they've got a subtractive property. This is a property you guys know and you've seen used quite a bit. So to avoid repeating a symbol more than 3 times, as in I, we write IV. Okay? So anytime a smaller numeral comes before a bigger one, it's a subtractive feature. But it only happens with one symbol less than what you're working on. So in other words, well, within the place value you're working on. In other words, if I were to want to write the number 90, the way that I would write that, just my page. Is I would write that as X and then C. And the reason I would do that is because how much is X worth? 10. And C's worth 100. And since the X is coming before the C, I can write that as X and then C, and then I've got 90 subtracted. But what you can't do is you can't just put that for every feature. Like 99, I would love it if I could write IC. But they don't do that. They do not write I and then C. They're treating the 99 as though this is 90 plus 9. Okay, so they're treating it positionally. That first 9 is worth 90. And how do I write 90? XC, we just did that, right? And then how do I write 9? IX. So you don't just get to use the subtractive feature anytime it sort of suits your fancy. Like to make it easier and more convenient. We're going to use it the way that they used it. And the way that they used it is to sort of break apart each of the values into their individual place value values. Okay? Okay, this is a subtractive feature. They've also got a multiplicative feature. And this is what allows us to get numbers bigger than 1,000. Okay? So if you want a number bigger than 1,000, you actually take a bar and you write it on top of that number, and it means that that number is multiplied by 1,000. And if you put 2 bars on something, it means it's multiplied by 1,000,000. Okay? So if you want the number 9,000, this is actually 9 times 1,000. Agreed? Okay, so how do I write the number 9? IX. And then I put a bar on top of it, which means times 1,000. Okay? So anytime you have something that's multiplied by 1,000 or multiplied by 1,000,000, that's how you think about it. You think about the multiplicative feature. You write the first number exactly like it should be written if it didn't have the 1,000 it's multiplied by. And then you put bars or 2 bars on top of it. Okay, let's do one that's looking a lot like what we saw on the other slides. We're going to deal with MCMX. So just for fun, because I think you should be able to do this, not because your book's going to necessarily ask you to, let's turn that into an actual hour numeral, a Hindu Arabic numeral. What would each of these be worth? What's M worth? That's 1,000. What's C worth? 100. What's M worth? 1,000. And what's X worth? 10. So do you see any place where the subtractive feature is used? The C and the N, because the 100 comes before the 1,000 here. So since it says CN, 100 before 1,000, how much are those two combined worth? That's 900. Okay, good, 900. So this is 1,000, 900, and 10. So this is 1910. So you could actually see that on a building, right? Established in 1910. Okay. All right, so that aside, we're going to look at what comes after something. So how do you make something 1 bigger in Roman numerals? You just add a 1 on the end, right? It's easy. So we have exactly what we had before, and we're going to add a 1 on the end. Now, of course, sometimes you can't just add a 1 on the end if it ends up making it too big. But on this one, it doesn't, because I don't have any 1s on the end to begin with, right? So this would actually be now the number 1911. Oh, I did the number after. I'm sorry, and I put it in the wrong spot, so let's move that. Whoops. All right, that's my question answered. I'm sorry. Before this value, no wonder you guys are looking at me like I was weird. We need a number before this value. So how do you get the number before this value? Well, we know the number ends in 10. What comes before 10? 9. How do you write 9 in their number system? What's that?
Can't you just do it like V and 4 eyes?
Can you? So it's a good question. So somebody tell me, can you do a V and 4 eyes? No. What is wrong with this notation with the way they used it? They'll never do 4 symbols in a row. So if we are trying to avoid the 4 symbols, that's when we would use the subtracting feature. So instead of writing a 9 as a V and 4 eyes, I would write it as an I and an X. So the first part stays the same, MCM, and then I'll write IX for the number 9 instead of having the number 10 there. And then we already did part C, didn't we? Wow, we're ahead of the game. 1910, this is worth 1910. All right, we're going to do one more problem. This last one down here, and then we have a great stopping spot for today. Right at the end of class, it's perfect. Here's what we're going to look at. I'm going to look at the number 1,492,019, and I want to write that as a Roman numeral. That's a big one, right? Yeah. So how do we do it? Well, what you need to think about doing when you're starting this one is breaking it apart where the commas are. Okay? The first part has the number 1. How do I write the number 1? I. Okay. But it's not really the number 1. It's in what place value? Millions. So how do I represent this 1 to be 1 million? 2 bars in the top. Don't make me guess how many bars are on top of things or where the bar stops are. Okay? Very clear on how you write them. 492. Okay, so we break it apart into the 4 pieces. We'll deal with the fact that it's 1,000 in a minute. How do I write 400? That is CD, because I can't write 4 C's, right? So I write C to represent 100, D is 500. Coming before it makes it 400. How do I write 9B? We already did this one. XC. That was 2 slides ago. And how do I write the number 2? 2 I's. Yeah. So this is 492. And how do I make it 492,000? 1 bar on the top. Good. It's almost like you guys are listening today. It's fabulous. I know you listen all the time. All right. There's a 0 there. We don't need a 0 in your number system the way they work with it. But we do have 19. What you want to remember, though, is that the 19, again, we're going to break it apart. The 1, how do I get the 1? That is that number 1 that means 10. I get an X. That's 10. And then how do I get the number 9 for the 9 at the end? IX. So this right here, I almost said ladies and gentlemen, but there's no boys in here. This right here, ladies, is the number 1,492,019 in Roman numerals. All right, so here's your assignment, and if you've already done this for me from Contemporary, do not share the fun. Let your classmates find out for themselves. I want you to look at Rayleigh Chapel and tell me what's wrong with the clock. When you come back, do not talk to each other and do not ask anybody. I'll see you guys all on Monday. Have a great weekend.